Good day to you. You are welcome to Brainiac Serial Coded class. And the question I will have here is find the maximum likelihood estimation of mu and sigma square if x1, x2 up to xn is a random sample from a normal population with mean mu and variance sigma square. So this topic is from maximum likelihood estimation. Then we are to obtain the maximum likelihood estimation for mu and sigma square from a normal distribution. So the first thing we are going to do here is we'll go to the solution. So we state the PDF for a normal distribution. So here we have 1 over, that's 1 over sigma square root of 2 pi exponential minus 1 over 2 x minus mu all squared. Then we have sigma over there. So now the formula for the likelihood function. So to obtain the likelihood function, the formula is defined as I equals to 1 up to n. Then we have f of x comma mu comma sigma square. So now this one is equals to, so this one, okay, this one is equals to, here we have the product I equals to 1 up to n. So what we have here is called the product, and this f of x comma mu comma sigma square, that's the probability density function for a normal distribution, and that one is defined as 1 over sigma square root of 2 pi exponential minus 1 over 2 x minus mu over sigma all squared. And the next thing I want to do here is we have 1 over, since we have the random sample, that one is from x1 up to xn, so we're going to have sigma square root of 2 pi then exponential minus 1 over 2. We'll go to this x, so we'll take this one as xi. When x is equals to 1, we're going to have something like this over sigma all squared times, this one stands for the product, so we'll put a dot in between that. This dot actually represents a multiplication, so we have 1 over sigma square root of 2 pi exponential minus 1 over 2 x2 minus mu over sigma all squared. Then we'll put a triple dot in between up to the last one, where we have 1 over sigma square root of 2 pi, so square root of 2 pi exponential minus 1 over 2 xn minus mu all squared over sigma. So now we have, when for the first random sample, the second one up to the n sample. So we can now say the likelihood function is defined as, so what we have here, since this 1 over sigma over 2 pi and 1 over sigma square root of 2 pi is common to everything, we can write it as 1 over sigma square root of 2 pi raised power of n. And again, here we have exponential minus 1 over 2, so we can write this one as summation xi minus mu square over sigma square. So what we have here is called the likelihood function for a normal distribution. And the next thing is to obtain the natural log of both sides. After obtaining the natural log, then we can now differentiate with respect to mu. Then we'll create whatever we get to 0 to obtain the value of mu, that is the mean. Then the second time we differentiate with respect to sigma square to obtain the variance. So now let's differentiate the likelihood function, and before we differentiate that one, we need to obtain the natural log. So to obtain the log of this, we have ln x minus s comma mu comma sigma square is equals to ln of 1 over sigma square root of 2 pi, this one raised power of n, then we have exponential minus 1 over 2 summation xi minus mu raised power of 2, sigma is over there, so we enclose a bracket. So from what we have then, we can write this as the ln of 1 over sigma square root of 2 pi raised power of n, then this one will be times the ln of, we have exponential minus 1 over 2, so this one will eventually change to addition, then we have summation xi minus mu all squared over sigma, then okay, that's for the other one. So this one will cancel this one. So we'll take this one to addition sign. So that's multiplication. So from what we have here, we can write this one as, we have ln of 1 over, that's 2 pi sigma square raised power 1 over 2, everything raised power n. Then this one will give us minus 1 over 2 summation xi minus mu raised power of 2. We can put sigma square here. So what we have here, this sigma, this power, the power of 2 is also affecting that sigma. So we are going to have minus 1 over 2 sigma square summation xi minus mu all squared. So this means we cancel this particular one. So from here we can actually write this one as 1 over sigma square root of 2 pi. We can write it as 2 pi sigma square raised power of half. So now then everything raised power of n over there. So we can still write it as the ln of, that's 2 pi sigma square, that's raised power minus 1 over 2, then raised power n minus 1 over 2 sigma square summation xi minus mu all squared. Now the next step will now be, we can still rewrite this one as the ln of, that's 2 pi sigma square, 2 pi sigma square raised power minus n over 2 minus summation xi minus mu all squared over 2 sigma square. And we can still write this one as, that's the ln of 2 pi, these 2 pi they are actually together, then raised power minus n over 2 plus, then we can still have the ln of sigma square raised power minus n over 2 minus summation xi minus mu all squared over 2 sigma square. Now from here we can take the power down, we can bring the power down. So this one will become minus n over 2 ln of 2 pi, then this one minus n over 2 ln sigma square minus summation xi minus mu. So we have summation xi minus mu all squared over 2 sigma square. Now, so after finding the log of both sides, so we have something like this. So the log is equal to this. So now let's differentiate with respect to mu. So differentiating ln this partially with respect to mu. So here there's no mu over here, so this one give us 0. So differentiating this side there's no mu, so this one give us 0. So now differentiating this particular side, this 2 is the power. Here we have negative, then this 2 is the power, we'll bring that one down. Then again, the next thing I will do here is we differentiate what we have inside the bracket with respect to mu. So this one give us 0, this one give us negative 1. So times negative 1, then summation xi minus mu, then everything we have over 2 sigma square. So we have 2 sigma square over there. So this one I think we equate it to be 0. Everything I will have there to be 0. So this one give us 2 summation xi minus mu over 2 sigma square equals to 0. So these two will cancel these two. So we now have summation xi minus mu then over sigma square, which is equal to 0. Now then the next thing I want to have there is the final answer for the mean, the maximum likelihood estimation for the mean. So that will be mu cap. So I need to have mu cap is equal to summation xi over n, which is equal to x bar. So now the next step is to differentiate what we have here with respect to sigma square. So to obtain the maximum likelihood estimation for the sigma square, so we differentiate what we have here. So with respect to sigma square, so we are differentiating what we have here, everything that is here. So with respect to sigma square, so now that means we have partial of ln this one x minus mu, this one s comma mu comma sigma square over partial sigma square is equals to, differentiating this particular side, there is no sigma square over here, so this one give us 0. So there is no sigma square here, this one will actually give us, okay, there is a sigma square here, sorry. So now here we have n over 2. So here we have minus n over 2 will be here in brackets. Differentiate this sigma square. So that will give us 2 sigma over sigma square. So since we have the sigma square here, so when you differentiate this sigma square, so when you have a logarithmic function like this, differentiate whatever you have beside it. Whatever you get, you write the result there over everything I actually differentiated. Now we have minus, we have a negative sign here. So now differentiating this with respect to sigma square using quotient rule. So this will give us, that will be 4 sigma. Then we have summation xi minus mu all squared. So negative will be here over 2 sigma square raised to the power of 2. So differentiating what we have here, and the formula that we're going to use to differentiate that one, that will be v partial u partial sigma square, since we are differentiating with respect to sigma square, minus u partial v partial sigma square, everything over v square. So now the numerator that we have here, so when you have two functions dividing each other, the numerator, that's our u, so this one is u, while the one at the down part is v. So using this particular formula, you will get, after differentiating this, we will obtain minus 4 sigma summation xi minus mu all squared over 2 sigma square all squared. So now we equate whatever we get after differentiating it to be 0 to obtain the estimate of the sigma square. So from here we're going to have minus n over 2. So this implies that we have minus n over 2. Then we have 2 sigma over sigma square. Then this one will turn to plus 4 sigma summation xi minus mu all squared over 4 sigma raised to 4. Then equals to 0. So here this 2 will cancel this 2. Sigma will cancel 1 sigma is remaining 1. So 4 will cancel 4. Sigma a 1, sigma a 3. So I need to have, this implies that we have minus n over sigma plus, that's summation xi minus mu all squared over sigma cube equals 0. So from here, we are going to have summation xi minus mu all squared over sigma cube is equal to, take this one to the other side, that will be n over sigma. So we'll cross multiply from here. We're going to have this, we'll multiply this one, so we'll cross multiply from here. So when you cross multiply, this one will multiply, and this will multiply this. We're going to have n sigma cube is equals to sigma square root of xi minus mu all squared. So this sigma will cancel 1 sigma, we have 2 left. So we have n sigma square is equals to summation xi minus mu all squared. So now the value of sigma square, we are looking for sigma square, the estimate of this, that will be summation xi minus mu all squared over n. So the estimate, so we have this one is equals to summation xi minus mu all squared over n. So that is the maximum likelihood for the mean and the sigma square from a normal population for a normal distribution. Thanks for watching. Kindly subscribe and follow for more. Thank you.